an AI-generated post for your viewing pleasure. Breakthrough in large language model adaptation, harnessing the power of in-context learning. Cutting-edge research is blurring the lines between two dominant approaches for adapting powerful language models, in-context learning and fine-tuning. Surprisingly, when provided with hundreds or even thousands of demonstrations, this learning technique can rival or even exceed the performance of fine-tuning, long considered the gold standard. This discovery could revolutionize how we deploy and fine-tune large language models for a wide range of real-world applications. Let's dive into the groundbreaking insights from this study that are poised to reshape the landscape of model adaptation. As language models continue to grow in size and sophistication, researchers are exploring novel ways to leverage their vast capabilities. One particularly promising approach is in-context learning, the ability of these models to perform new tasks by simply providing a handful of examples within the input context. This technique has captivated the AI community, offering a tantalizing glimpse of a future where powerful language models can be easily adapted to myriad applications. However, the traditional boundaries between in-context learning and the more established fine-tuning approach are starting to blur. A new study from leading researchers delves deep into this uncharted territory, uncovering surprising discoveries about the properties and potential of in-context learning when scaled to extreme context lengths. At the heart of this study is the concept of long-context, in-context learning, the idea of providing hundreds or even thousands of demonstrations to a language model during inference, far exceeding the typical context window. As model context lengths continue to expand, the number of examples that can fit within that context is starting to approach the size of entire training datasets. The researchers systematically evaluated the performance of this long context approach across multiple datasets and model variants, comparing it to the more traditional fine-tuning method applied to the same base models and data. Their findings reveal a remarkable and counterintuitive discovery that could reshape how we think about adapting large language models for real-world use. Let's take a closer look at the key technical insights that emerged from this groundbreaking study. The researchers' systematic evaluation uncovered several striking findings. Notably, they found that for many datasets, particularly those with large label spaces, performance on in-context learning continued to improve dramatically as the number of demonstrations provided increased. In fact, this approach often approached or even exceeded the performance of finely-tuned models, a surprising result given that fine-tuning has long been considered the superior method for leveraging large datasets. The researchers also used the long context setting as a testbed to uncover intriguing properties of these models. For instance, they discovered that long context, in-context learning is less sensitive to the order of examples provided than short context approaches. This suggests the model is able to extract more robust, task-relevant representations from the extensive context. However, the researchers also found that grouping examples by label can have a surprisingly negative impact on performance, underscoring the importance of diverse demonstrations for effective in-context learning. Delving deeper, the researchers determined that the performance gains of long context, in-context learning primarily stem from the model's ability to effectively retrieve and attend to relevant examples from the extended context, rather than continually refining a task-specific decision boundary. This contrasts with some prior hypotheses and points to opportunities for improving the efficiency and scalability of this technique through advances in example retrieval and catching. These insights not only shed light on the capabilities of long context, in-context learning, but also offer valuable clues about the broader properties of large language models. Let's explore how these findings fit into the current research landscape. While prior work has explored the potential of in-context learning, most is focused on settings with severely limited context lengths and demonstration sets. By pushing the boundaries to hundreds or even thousands of examples, this new study reveals a previously unappreciated side of the technique, one where it can rival or even surpass the performance of fine-tuning, long considered the gold standard for leveraging large datasets. This finding challenges conventional wisdom and adds an important new data point to the ongoing debate around the relative merits of in-context learning and fine-tuning. Crucially, the researchers' analysis indicates that the performance boosts of long-context in-context learning stem more from effective retrieval than from continual refinement of task-specific knowledge. This contrasts with some prior hypotheses about the inner workings of this approach. Beyond just characterizing the capabilities of these models, the study also serves as a valuable testbed for exploring the properties of long-context language models more broadly. The researchers' insights about the impacts of example order, label grouping, and the relative contributions of retrieval versus boundary refinement offer important clues about how these powerful models operate under the hood. As the field continues to push the boundaries of what language models can achieve, understanding these model behaviors will be crucial. The researchers' deep dive into long-context in-context learning has revealed a remarkable and counterintuitive finding. When provided with hundreds or even thousands of demonstrations, this approach can rival or exceed the performance of fine-tuning, long considered the gold standard for leveraging large data sets. This discovery challenges conventional wisdom and opens up exciting new frontiers in how we deploy and adapt powerful language models. By understanding the properties and limitations of long-context in-context learning, its reduced sensitivity to example order, the importance of diverse demonstrations, and the primacy of retrieval over continual refinement, researchers can work to further enhance this technique and unlock its full potential. As language models continue to grow in size and capability, the traditional divide between in-context learning and fine-tuning may start to blur. The insights from this study suggest that in-context learning, when taken to the extreme, could become a powerful alternative to finetuning in certain domains and resource regimes. Ultimately, these findings point the way towards more efficient, robust, and effective methods for adapting large language models to a wide range of real-world applications.